Okay, welcome back to the third part of this lab. And so in the last lab, we looked at printing things on screen and also some basic mathematics. And we noted that for things like trigonometric functions, we had to use this thing called NumPy, which we imported as NP. So we used NP dot sine of 0, for example. And we also noted that these trigonometric functions, they were in radians and not degrees. So in this lab, we're going to talk about how we can convert an angle from degrees to radians. And we're going to use this as an opportunity to learn about writing our own functions, okay? So if you're following along in the guide, we're on page 8 of the guide, okay? So we're going to write our own functions now. So I'm going to open Spider again. So this was the code we wrote last time. I think I might make a new code just to keep things separate and tidy. So I'm going to create a new file. Again, it opens up with all this junk. I'm going to get rid of that. And I'm going to save it as, well, let's call it lab python 2.py. So remember that the .py is very important at the end. So we've got to tell the computer that this file is a Python file. So we need that .py at the end. Save that. I might just clear my console while I'm here because I don't like junk in the way. And again, I'm going to be using mathematics here. So I'm going to start by writing import NumPy as NP. And remember the as NP part is just so that we can use NP as a shortcut. We don't have to write NumPy all the time. We can just write NP instead. Okay, so I'm going to save that, run it. Okay, well, nothing happens because nothing's in the code. Okay, good. So when we're converting an angle from degrees to radians, we can easily write down the code for that, right? So if you're converting an angle from degrees to radians, you just simply multiply that angle by pi and divide it by 180 degrees. And that will give you the angle in radians, okay? And so if you are only doing this one time, then we could just directly write that in the code. But if we wanted to do this for, let's say, 10 angles, or 100 angles, or 1,000 angles, if we want to convert 1,000 angles, which are in degrees, to radians, I do not want to be writing times pi divided by 180 1,000 times. Or let's even scale it up. If I want to convert 1,000,000 angles to radians from degrees, I don't want to write that 1,000,000 times, right? I could not possibly do that. So the way that we can deal with scaling to large number of operations is we can write our own functions, okay? So we write a general function that will do the same job every single time, but perhaps with a different degree, angle in degrees every time. Okay, so how we define a function. So this is very important, that the first thing that enters into your code is the import command, or maybe sometimes you have more than one import command. So the first thing are the import commands. The second thing is your functions, okay? So how do we tell Python that we're defining a function? DEF. So DEF tells Python that this is a definition of a function, okay? Okay. The next thing you write after DEF, is the name of your function. And so you can call this, you can give this any name that you want, really. But usually we would give meaningful names to the function. So my deg to rad. So this function is basically saying, I'm taking this is my function that is converting degrees to radians, okay? So at the moment, this is just a name. Okay, so now in regular curved brackets, I'm gonna write something here, degree angle, deg angle, or deg, not def, deg angle. And I'm gonna end that with a colon, okay? Okay, so this dig angle thing, this is going to be what we call an input variable. So you can have more than one input variable for any function. We'll talk about that perhaps in a future video. But here the input variable that we're going to be using is the angle in degrees that we want to convert to radians, okay? So I'm just giving that the name dig angle. And the other thing is, right, we have to have this colon at the end of, the function definition. So now if I come to the end of this line here and I press enter, you'll notice that my cursor, or my flashing cursor thing here, is indented. So everything that is associated with this function has to be indented. And thankfully Spyder does this automatically for us. So what I'm going to do is I'm going to say rad angle. So my angle in radians is equal to the degree dig angle. So that's my input variable, right? The angle in degrees that I'm inputting to my function, I'm giving this to my function, is called dig angle. So if I want to convert dig angle to radians, degrees to radians, I'm going to times this by pi. Okay, I might do this in brackets. The way I write pi in Python is again using NumPy. Okay, so I'm going to write np.pi, and that gives me pi. That is the definition of pi, np.pi. Look in the NumPy function and pull out this thing called pi, which of course is that 3.14 thing. Okay, and I'm going to divide it by 180. I'm going to divide it by 180 degrees. So if I take my angle, multiply it by pi, divide by 180, that will give me the angle in radians. Okay, but we're not done. I'm going to press enter again. Notice that we're still indented. Now I need to tell the function what to send back to the rest of the code. So we give the function an angle in degrees. Now we need the function to return rad angle. Okay, so we give the function this angle in degrees. We calculate this thing called rad angle, which is just the radians, this degrees, and we return, so a very important command, return this rad angle thing, right? So this rad angle thing is the same as here, this one. Okay, so I'm just going to save that. Where are we? There we go. So we always have to input, well, we don't always have to input a variable, but in this case for our converting degrees to radians, we're always going to input the degrees, angle in degrees, and we're always going to return a variable. And in this case, it's the variable we calculated here. So let's test that. Let's say A is equal to, so now A is equal to my degrees to radians. I don't know what, let's try 90 degrees, right? So what should 90, if I convert 90 degrees into radians, so that should be pi over 2 or 1.57 or something. Remembering that we have to also print this thing. So A equals plus STRA. Okay, I'll save that now. So what this is doing, everything up here is just a definition. What this is doing is it's saying to the function my degrees to radians, input 90 degrees. That should return the angle in radians, and that angle in radians we're going to call A. Okay, so let's see if it works. So that seems to have worked, right? We inputted 90 degrees into this function and it outputted 1.5708 basically. And so this is, if you have a calculator handy, to calculate, this is equal to pi over 2, which is exactly 90 degrees. Of course, we could try this with different numbers. Let's try 180, and there we get is equal to 3.14159. So this is the value of pi, right? So this function that we've written, my degree to radians, that seems to be working perfectly. I'm just going to clear the console. And maybe I'll just change this back to 90 because I quite like pi over 2. So in fact, this really simple and relatively quick example of how to define a function, I basically did this for the benefit of showing you how functions work. You may need to do this a few times just to get used to it. But actually, we didn't really need to do that for converting degrees to radians, because it turns out that if I define a new variable b is equal to np dot dig to rad 90, and I output that, it turns out that numpy actually already has a function to convert from degrees to radians. So if I write np for numpy dot degrees dig to radians rad of 90, then that should also output the value of 90 degrees in radians and store it as the variable b. Now, let's just test that. And so here you can see that exactly, okay, forget these extra little bits here, but this value that we have calculated using our function exactly matches up to a certain number of decimal places the value that numpy gives us, okay? So actually it doesn't matter whether you use your own function definition or whether you use the numpy version, it's going to give you a very good answer either way. So this was really just to teach you how to create a function in Python. So my suggestion is that you now go ahead and yourself try to define the function my rad 2 degrees. So blah, blah, blah. So my suggestion would be that you try and do that yourselves and then test it against the NumPy version, which would be np.rad2dig. So I'm going to leave you to do that. But I will just point out that one advantage of using the NumPy version is that we can actually convert multiple, a list of degrees to radians at once, okay? At the moment, our function will only allow us to convert 1 degree to a radian at a time, but the inbuilt command will actually let us do multiple. So let's have a look at that. So let's say C is equal to numpy dot degree to radians of, so here I'm going to actually give it a list of numbers. So inside these square brackets here, I've just added some square brackets. I'm just going to write a list of numbers. So 0, 20 degrees, 40 degrees, 60 degrees, 80 degrees, 90 degrees, and 100. Well, actually, no, let's do 180. Okay, so this command actually is going to convert 0, 20, 40, 60, 80, 90, and 180 degrees to radians all at the same time. So let's also just output that string. If I save that and run that, then I get a mistake. Okay, great. Let me just check. I have an unexpected indent. So, well, this is a nice learning opportunity. Python is very sensitive to the indentation. So here, at the start of this line, you can see I have a little space there for some reason. I'm just going to get rid of that space. So everything that is not inside a function has to start flush with this wall here. So let's save that and run that again. Okay, and it's happy now. So we still got an A that we calculated, the 90 degrees to radians. We still got B, which is the NumPy version of 90 degrees to radians, so they still look good. But now C, you can see, is a list of numbers, and it has converted 0, 20, 40, 60, 80, 90, and 180 degrees all into radians, okay? So it converted all those at once. So it can be quite helpful to use functions that can operate on multiple numbers at once. It just saves a lot of time. Okay, so I'd really like you to go away now and try to define that my rad 2 degrees function. So maybe you're going to be input rad angle. You're going to calculate dig angle equals whatever you're going to, however you define that. I'll leave that to you, and you're going to return up here, my rad 2 degrees. You're going to return that dig angle there. So give that a go, and I'll see you in the next video.